Okay, so in this question we're given, we've got some sort of truck and it's going to operate by a company and it's travelling at a certain speed, which is V, and it costs a certain amount of money to operate the truck at a certain speed. So you can imagine that if the truck isn't going anywhere, or if it's travelling very, very slowly, it costs a lot of money to run it because it's just going so slowly, so it's not getting very far very quickly. Also, if the speed is very high, then it's going to use up more petrol, and so even though it might get there faster, it's actually got a high cost associated with it. In fact, we're told that the maximum speed that the truck's allowed to handle drive is at 80 kilometers an hour. Okay, so we're given a formula for the cost, which is V minus 20 cubed over 5,000 plus 400 over V plus 200. Okay, so what we have to find out is the hourly cost. So what speed do we need to travel? So the hourly cost is minimized. So we need to find the minimum value of C. Now, there are three possible values for this. There's two, which are the end points. So can we have V equals 0, V equals 80, because we know those are the two endpoints. It can't go between lower than 0 or higher than 80. And also, are there any local min points? Okay, so there could be more than one. So those are the three areas that we need to look at. So let's look at V equals 0 first. So we put V equals 0 in here. That's actually undefined because we've got a 0 on the bottom, so it's kind of like infinity, so we can ignore that one. The V equals 80 we do need to figure out. So V equals 80, when V equals 80, the cost, and this is easy because you can plug it into your calculator, is like $248 and a bit of small change per hour. Okay, so now we need to figure out the local min and see whether that's actually less than what we get here. So we've got this as a possible point, and then we need to find out your local minima. So the local min differentiated. So you can use a calculator for it if you want to, but this one here is easy enough to do by inspection. So it's 400V to the minus 1, so that'll be minus 400V to the minus 2. Got that, plus 0, and differentiate that, and then he set it equal to 0. So plug that into your calculator, and what you'll find is that you'll get two values. So V equals 40 point something, 27, or minus 20 point something, and we can ignore that one because it's got to be a positive speed. So that's 40.27. So let's plug that in again, use a calculator, and what do we get? $211.60. Okay, and that one, $211.60, is in fact less than the value at 80, so that's probably the answer. The one last thing we have to do is just make sure that's not a maximum. So we need to check that it's a minimum and not a maximum. You can't tell that just because the 80 value is higher. That doesn't necessarily mean this is a minimum, because the 80 value is just an endpoint. So the function, if it looks like okay, it's 0, it's undefined. We're kind of guessing that the function is going to go something like that. No idea what it looks like, but it could actually be a maximum. It could be actually turning up like that, and the way it cuts off at 80 may actually still be lower than the maximum. So how do we find out whether it's a minimum? Well, you double differentiate. So the derivative of the derivative, what do we get? So where's our derivative function? So there's a derivative. So we can do this again in our head. 6 times v take 20 over 5,000 minus, that's this v to the minus 2, so it's minus 2 times v to the minus 3. And you can plug that in, and you get the answer, which is bigger than 0. So yes, this is a minimum, because the second derivative is greater than 0. So there's our answer. So our answer is that V equals 40.27 kilometers an hour, and we have to find out what the cost is, and the cost is $211.60. Okay. Okay, so the second part of the question says find the difference in cost if it is travelling at its posted speed limit. So if it's travelling at 80, what's the difference in cost? Well, that's pretty easy. We've already worked it out. We worked out that the cost is, where was it? Cost of 80 is up here. So the cost of 80 is 248.20. Therefore, the difference in cost is whatever that is. Equals, whatever it is, so around about $37. I won't go into it exactly, but roughly that. Okay, so then the third part of the question simply says, suggest a reason why the company that operates this truck may not operate it at the speed that achieves the minimum hourly cost. So why wouldn't they operate it at 40? And I think the answer is, I think all we can say is that when you operate it at 40, it costs you $211.60 an hour, and operating it at 80 is only $37 an hour more expensive, but it's travelling twice as fast. So presumably, if you're trying to get deliveries twice as fast, you'd be able to do twice as many deliveries, or you might be able to get your supplies to your warehouse twice as fast. So it's just a business decision that you might say that going at 80 does twice as many deliveries. Okay, so it might be better. Might be better, even though more expensive. Okay, we can't tell that for sure, because that $37 an hour cost might be significant, but it's unlikely. If you've got a truck, then you're probably going to get much more than the $37 in value by going twice as fast.